Let's see if my audio settings are working today. So far, so good. What are we doing? Start working on slides. Write a handful of Chrome extensions because I don't like typing out drive.google.com every time. It's a little annoying. Opening a new tab. Yeah, see, I need to track search. Good job, past me. If it's not create, it's going to be Chrome tabs, something else. See if it's a link and create. Sometimes they'll link similar functions together. Create. Creates a new tab. It's not super helpful. Tab occurs 500 times on this page. That's not useful either. The current set current. It's the tab that the script comes being made from. Tab void. New tab, get the current tab. Current tab, first position, click. That's interesting. I'm not sure when I would ever want that. Interesting. super used to the callback mode of thinking. I tend to spend my time in more imperative languages. Single-threaded, front to back. Current tab, according to this cookbook recipe, different from the tab the script is being called in. That's version 2, which I guess doesn't have the catch flow keyword. Service workers talk to content scripts seems a little advanced for what I want to do. whoever has description of what it does. Tab manager for Chrome DevDocs is vague. I don't understand. It's on the web page here. I mean, I guess I could almost read it and see what it does. You don't have to say Chrome extensions have anything malicious in them. Yes. Contents update. Update. Nothing. I think I need to set the tab or the window to active since I'm using the default, which is the already active tab. Highlighted, muted. Tab that opened this tab. It's pinned, but it's selected. URL. I'm not sure what the difference between a JavaScript URL and a Oh, I see what it means. It seems like it means the not a URL from a script, a URL to a script, which is not what I mean. Okay, so if I use app.update with same code that was over. Here. Just give it a URL, everything else should default to current settings. Maybe I'll just leave the icons in there and not cause myself trouble. The icon's just a magnifying glass picture anyway. It's fine. I'd have to change it if I was going to publish this extension for some reason. Over to the extensions page. Open unpack extension. I set the keyword. I did not. So the keyword is drive. I messed with that part. In fact, I thought I avoided messing with that part because I figured it might be annoying. Oh, I did, but I deleted the files, so I couldn't find them. That's my fault. I'm done. I'll just go get those real quick. Hit drive and hit space. What do I want to search for? Weird. Warning, I'm about to turn off my light colored background blocker for a moment. Maybe a little bright. But don't those lines look brown on the left and orange on the right? Totally not, though. Right? Single fill color. Solid color. It's not a gradient. It's too dark yellow and green, huh? I'm gonna stick with the custom brown because I tuned it a little bit to make the effect as obvious as possible. I mean, all I did though was start with orange and then vary its brightness until I got something that looked orange on a black background and brown on white. I was trying to decide what the stripes look like in the middle where the transient is gray, but my eyes keep unfocusing. Used to refuse to look at it. Let's turn the filters back on. 16 by 9 to start. Side effects of this filter is going to be set up to make bright websites not burn out all of your eyes. That looks a little bit weird on dark mode websites. Yeah, this is actually an image of a light mode website. So the whole page is white to me with black lettering. I've just set up a filter so that anytime I go to a page like that, it automatically takes all the white parts, makes them black, takes all the non-white parts and lightens them up a little bit so that you can see them on a black background. Right, so all these letters are black, but it's changed them to light gray so that they show up. laying abed, awake, wondering why band gaps look so narrow. And then I was thinking, shouldn't band gaps actually be like almost infinitely thin? Because band gaps are caused by electrons absorbing photons. So if you have a giant cloud of, say, hydrogen, it's really hot enough for fusion, right? Fusion makes things really hot. And things that are really hot glow, but they glow in a continuous spectrum. But if you had a cloud of hydrogen that was glowing, it would absorb a couple of very specific frequencies because there are frequencies that hydrogen electrons absorb. They only absorb the exact frequency of light that they need to jump to the next energy level. So then I was thinking, then shouldn't band gaps be almost infinitely thin? They should only be at that one frequency. But then I got to thinking, but all those atoms those electrons are attached to are moving around. So maybe the band gaps have width because of the Doppler effect. Right? So things that are moving towards you appear bluer, and things that are moving away from you appear redder. I was thinking, maybe the relative motion of those hydrogen atoms and the photons that they're blocking, some of them are moving towards the photons, and some of them are moving away from the photons, and some of them are moving at the same speed of the photons. Probably not the same speed, but some of them are moving pretty fast. Yeah, actually that's a bad way of phrasing it, because photons are light, so they move at the speed of light. Right. So the photons and the atoms are all moving towards each other because the atoms cannot go fast enough to escape. So the photons are always catching up. It's just sometimes the photons are trying to run away, so it's not catching up quite as quickly. And some of the photons are trying to ram head on into or some of the atoms are trying to ram head on into the. For those, the light would seem a little bit bluer. Photon, slightly higher energy photons would get absorbed there. So, and I was wondering if that was correct. So do. Though anytime somebody puts something like this in their abstract, multi-fluid quantum hydrodynamic model, part of me has to wonder if they're just intentionally making their abstract hard to understand. Right, the goal of an abstract is to make it as simple as possible so that the widest possible audience knows what the paper is about. They may not be able to read the actual paper. Right, but I have majors in both math and physics, as well as computer science. But This one is mostly, to do with math and physics. So like this piece here, this is saying, if I read it right, they're saying this is not an actual quantum particle, this is a bunch of electrons that we kind of squished together in a way that simulates quantum particles. I may not have that right, though. Yeah, so this is electromagnetic quasi-particles. So they're doing something that causes the electrical field to act like a quantum particle. It's kind of not what I was wondering about. Kind of is. Oh, this might be it. Atoms are moving. Okay. You can use Maxwell's law to figure out the distribution. In this case, the distribution that we would care about would be the line that connects us to the sun, right? Because of the giant ball of hydrogen gas that I was talking about the sun. In case that wasn't clear, that probably was clear to most people. Well, maybe not. I mean, how many people really think about the fact that the sun is it's a cloud of hydrogen gas that is currently going through a multi-billion year thermonuclear explosion? It is. It's exploding. Well, it's trying to explode. Currently, though, it weighs too much to explode. Don't we all? That's why I'm on a diet. Thinking back, that sounded kind of wrong, but I'm probably going to clip it and post it anyway. But the distribution that we care about when we want to see the sun's band gaps is the band gaps are the dark areas in the spectrum. The dark areas in the spectrum where the hydrogen gas has absorbed some of the photons the sun is letting off. So if you make a typical prism does not spread the rainbow out enough for you to see it. It's not wide enough, and it's too tall. Mostly you need a device called a spectrometer to see this sort of thing. It's just a very fancy prism. It's a very clear prism. And it's basically if you put a prism into a microscope so that it projected the resulting rainbow into a lens where you could see it. The ones for looking at the sun also have a filter that keeps you from going blind. Do not point either a regular prism or a microscope, combination of the two, at the sun and then look through them. It's not a good idea. Just saying. I know you, Internet. I've met you. I don't really want to think too much about how many of you have looked directly at the sun before. You know who you are. Seriously. What was I saying? I was saying the distribution we care about is the line that goes from the sun to us, because that's the only line that goes from the sun to our spectrometer where we can see it. But if you wanted to isolate that out, here's your equation. I'm guessing most of you don't care about the actual distribution. What we care about is that there's such a thing as the most probable speed and the average speed. The emitted frequency, okay. Insight to the observer, that's what we talked about, so we learn the observer. Then there's the Doppler shift due to the relative motion of so in this case, the V0 is going to be the speed of light. I think, because we're talking about speed of the speed of the photon, right? That means that this c here, which is the speed of light, that there, which I think is the speed of light, those are going to cancel out. I know, scratch that, that's not a velocity, that's... This one is a frequency, this one is a velocity. Physics involving light gets a little bit wonky like that, because light doesn't have any mass, therefore it always moves at the maximum possible speed. So all of its speed-like properties are instead part of its frequency. Frequency is the property that we perceive as color, right? So blue has a higher frequency than red, but frequency is talking about the actual physical property, and color is talking about how our brains perceive that property. So if you are talking to a scientist about photons, they're saying frequency, in your head you can think color, but if you say it out loud, they will probably correct you and say, no, color is a perception thing. You don't get color until after your brain has processed the signal, right? So color is the signal in your brain. Frequency is the property of the light. Which is why when you ask what color is something, On the one hand, that's a nonsense question. Things don't have colors. Color is a property in your brain. Now, your brain may assign a color to an object, but that object doesn't actually have that color. The object has frequencies that it reflects and frequencies that it absorbs, and in some cases, frequencies that go right through it. On the other hand, that's a very pedantic argument, and when somebody asks me what color something is, I just tell them the answer because it's silly to get into an argument over that. Unless I'm trying to be annoying. Generally speaking, if I give that physicist answer, I'm trying to be annoying on purpose. It's the sort of answer that I would give to my brother, for instance. Not to my mom, because my mom would be like, haha, very funny, I don't care. Tell me the answer. My mother very kindly listens to me ramble on about different physics concepts. Just not when she's asked me a question where the physics concept has nothing to do with the answer that she wants. And I think that's fair. I think that's fair. If you have someone annoying like that in your life, you should set boundaries. Tell them, when are you okay with silly and pointless physics or mathematics answers? And when do you just need them to answer the question that you meant to ask and not the question that literally came out of your mouth? My dad used to do that sort of thing to me when I was a kid. If I asked him whether he wanted orange juice or milk for breakfast, he would say yes, because he did. He did want one or the other. And I eventually told him that if he kept doing that, he would start getting nothing. So yes, there is a concept of Doppler width. If there's turbulence, the width can be even wider. The sun is pretty turbulent. Here on the left. Thermal line profile. We get a fairly steep curve. Collisional broadening. I don't know that term. This is a totally different effect. So when I told you that electrons could only absorb photons at a certain frequency, that was only about 80% true. There's a point beyond which the photon causes the electron to just go flying off of its atom. Any photon that is at least that powerful can interact with the electron. The extra energy in that case from having a frequency that's too high goes into the kinetic energy of the electron. So if you hit something with an X-ray, as opposed to, say, an ultraviolet ray, the resulting electron will be much faster because X-rays have more energy, because and energy is directly tied to frequency for photons. Okay, so my conclusion is my reasoning for why band gaps have some width was basically correct. It was good, because I based it on the idea of laser cooling, which are two words that you don't usually connect together. Yep, you can use lasers to cool things, but there's a catch. The substance that you're cooling needs to be almost completely clear at and below the frequency of the laser. Right? So you need a substance that has a very sharp change, sharper than this thermal line profile, preferably. But if this was an example, right? If this was an example of an absorption curve instead of a I guess this is an absorption curve, which is why it looks like an absorption curve. But if I aimed a laser at this that was at something like these 9.2, 9.4, 9.6, yeah, somewhere around the 9.5, right before it started going up, then the laser would only hit electrons on atoms that were coming right at the laser. Right, and then those electrons would jump up an energy level, and then they would drop back down the energy level and give off a photon that was equivalent to the one that caused them to get excited in the first place. That's the technical term, by the way. When an electron jumps up an energy level, it's called getting excited. So electrons are excitable things. So when the excited electron falls back down to its base state, it lets off a photon. And if it lets off that photon back in the direction that the laser came from, now it's had one instance of getting hit by a photon and one instance of releasing a photon, both towards the laser. And those photons, they don't have any mass, but they do have a teeny tiny bit of momentum. So they slow the atom down when they interact. And even if the photon it gives off is directly away from the laser, then you still had one incoming and one outgoing, so it cancels out. Right. So very slowly, the atoms in your material will slow down, because you're only hitting the ones that are coming towards you. So they'll very slowly all start going in the same direction. And I think when they're doing actual laser cooling, I think they just fire the laser through from all directions, like bounce it off a bunch of mirrors so that it hits molecules going in all directions. right? But always in a way that causes them to slow down. In other words, it never hits them from behind. It always hits them when they're coming towards a given laser. Uh, works really only for very small samples at already very low temperatures. Right, because you know how I said this thermal profile line is probably too wide for this? Right, if you bring the temperature way, way down, then all of these thermally influenced lines here, right, that's all of these Kirby boys will all get narrower and narrower as the temperature gets lower. This is the temperature factor there. So when the temperature goes down, the width of the frequency goes down. Also, in a small, cold sample like this, you won't have very much turbulence. So you'll have little to no turbulence. Your goal is to get all of the relative motion of the atoms, motion relative to each other in this case, and preferably to the container that they're in so they don't bounce off the walls. You want that motion to be as low as possible. But temperature is a measure of the relative motion. The random average molecular kinetic energy, if you will. So, in other words, how much all the particles are bouncing off each other. Temperature is not a base unit, like a base type of measurement. Temperature is a bulk property. It only makes sense when you have a whole bunch of atoms. That's why newspaper articles that say scientists discover a stream of gas at 5 gajillion temperature measurement units. Those are only 30% true. Because generally speaking, those articles are about things like there are very thin gas filaments that stretch between galaxies for some reason. I don't think we're totally sure why. And sure, you could say that they're very hot because the relative speeds between the particles in them is very high. But the truth of the matter is that there are so few particles that those particles are effectively moving through a perfect vacuum. Right? So the relative speed of the particles doesn't matter because they'll never encounter each other. It's just not dense enough for temperature to be a meaningful measurement. Right? Like I said, temperature is a bulk quantity. And there's not enough bulk. The intergalactic void is super empty. Like, you think outer space between the Earth and the Sun is empty? It is, it's pretty empty. But compared to in between galaxies, yeah, the intergalactic void, almost no particles. Okay. I don't like that the AI overview is just rewording the top couple of answers here. Also, because when it rewords it, sometimes it gets it wrong, which kind of annoys me. Which is why I thought I set my default search to give me web results. So you can tell it to give you the web results instead of all the results. And there's, with this UDM thing, there's also settings for all the other shopping forums, images, whatever. Settings. Search settings. Search engine. Doesn't let me alter the default one, so we get to make a custom one. Add. So for web settings. Now I want that to be my default. Now that I think about it, that's basically the same as the extension that I was writing. Just use this. is it doesn't let me not search. So the one that I wrote, drive, also doesn't let me not search. Interesting. But if you just search for an empty space, it interprets that as not searching. So if I type dots and I hit double space, okay, this one doesn't let me put an empty space in there. And the extension does. So that's interesting. The extension is more powerful because I can tell it to do things other than search. I didn't check whether I could set the extension doesn't let you set it to blank. I didn't check whether it lets you set it to space, so I could double tap space and replace the Chrome Omnibar with my custom code. I may do that eventually. If that doesn't work, I'll probably pick the letter A, or possibly the letter F. Because those are my default mashing the keyboard buttons. Interesting. Okay, so Google Docs one kind of works. Oh, here's an interesting question. What if make this just the search? Interesting. So if you ever want to make your Omnibar not search, just only go to web pages that you type in manually. You can do that. Still gives you suggestions though, which is something that a lot of people want to turn off. I've seen that people have written extensions to get it to do that. It's like escape. That's okay, because that's the wrong URL. M part, search part. doubt I care about the rest of those. Web search only. Because I thought I had already done that. But that's why bandgaps have width. In case you're wondering, and I'm guessing you're not, but I'm going to tell you anyway. There are also emission bands, which are the opposite of band gaps. So instead of shining a continuous spectrum through a gas and watching it absorb certain bands, if instead you take that same gas and you put it inside of a light bulb and you give it a bunch of electricity to make it really energetic, it starts giving off light at the same bandwidth that it would have absorbed. Coincidence? No, it's not a coincidence. It's because of the same thing. It's the electrons. The electrons can only go up and down at certain energy states. So if you try and shove more electrons in, then the old ones have to break loose. And they start jumping up and down at those predetermined levels. That's how fluorescent light bulbs work. The ones, in your warehouse or your office or wherever, those ones mostly have mercury vapor in them. Those also have a trick to them, because mercury vapor, well, so first of all, they have liquid mercury in them most of the time. But then when you turn them on, they heat up real quick, and the mercury evaporates into a vapor. And then you run electricity through that, and it ionizes it. Ionizing means that it breaks some of the electrons free, so that the electrons can start running through the gas. And that's, electricity in, electricity out. And then it starts giving off photons. The catch is that mercury gives off ultraviolet photons, which you cannot see, which you may be wondering, well then how can I see in the light given off by my fluorescent bulbs? And the answer is because the inside of your fluorescent bulbs is coated with phosphorus. Phosphorus is solid, so it doesn't make a good choice for running the electricity through directly. Both because it doesn't conduct super well, and also because light bulbs work better when the gas is distributed equally inside. This is fluorescent light bulbs. LED light bulbs and incandescent light bulbs, totally different. Right? So the mercury is nice because it's easy to store, and it's stable, and it's conductive. And as a vapor, it gives off a nice, steady, even ultraviolet light. It's not nice because we can't see it, because ultraviolet light is bad for us, and because mercury is bad for us if the bulb ever breaks. It's poisonous. So that's what the phosphorus is for. The phosphorus is just, if you've ever noticed that the light bulbs have a white coating on the inside, it's just solid phosphorus coating. Phosphorus absorbs ultraviolet light and gives off visible spectrum light. Most phosphorus gives off various colors of green, but over the years we figured out all sorts of additives and mixtures so that we can get a variety of different colors, which looks more or less like natural light to us. Color quality if you're a photographer, color quality is not as good as an incandescent light. If you're not a photographer, the energy consumption for a fluorescent light is much better than an incandescent light. They can be annoying when you first turn them on, though, because, like I said, they have to heat up. Neon lights work the same way. If you've ever seen neon or freon or xenon or helium in a light, all those old-fashioned billboards, they work the same way. It's just they have other gases instead of mercury in them. And you can put just about any gas in there. Some of them work better than others. Neon works well because it lights up a nice bright orange. It's very convenient. I forget. I forget which other gases give the best colors. It's mostly neon, argon, halon. Maybe helium was a good one. I remember hydrogen being kind of a dark red. It's neat to look at. It's not super useful. It's kind of dark. Some of hydrogen's absorption and emission bands are down in the infrared, if I recall correctly. So if you wanted it to let off heat, right, infrared is something that's pretty easily absorbed, so we detect it as heat. Yeah, lots of things on Earth absorb and or emit infrared. Also, earlier we were talking about how things emit light due to their temperature. Most of the things that we consider Earth-like temperatures emit in the infrared range. I want to say things start to glow somewhere around 600 or 700 Fahrenheit. But I don't remember. I guess that's easy enough to look at. Mm. 800 Kelvin, 525 C, or 977. Okay, so a little hotter than I thought. Right? That's why things that are glowing will definitely burn you if you touch them. On the flip side, just because they've stopped glowing doesn't mean they're not still hot. For anyone who has ever messed up taking something out of the oven, right? The heating element of the oven may be glowing, but the rest of the oven is still hot. In fact, that's how ovens work, is the heating element heats up the walls of the oven, and then the walls of the oven radiate infrared light onto your food. The fire is not directly heating your food. And if you're thinking, what about the hot air? Not a big factor unless you have a convection oven. Right? Because the air right around the food will heat it up, but in exchange the food cools that air down. So unless the air is moving around, the air right next to the food will be a little bit cooler than the rest of the oven. So it doesn't have that much of an effect. What a convection oven does is it has a fan that moves the air around so that the air next to the food is always as hot as the rest of the oven. And in that case, the air does transfer some heat to the food. That's why convection ovens cook things faster. Right, and that's what your so-called air fryer is doing, is it's heating up the air, then passing it over the food to heat up the food with the hot air, and then cycling that around and around. And if you're gonna buy a quote-unquote air fryer, I recommend you get one that's labeled as countertop convection oven. Right? Air fryer is a marketing term that they use to charge you more. Countertop convection ovens generally are better quality products. It's a secret. Don't tell anyone. Or tell everyone. Just don't tell the air fryer salespeople that I was the one that told you. That part's really a secret, okay? Alternatively, you could get an actual full-size convection oven. It's just that's a lot of extra power if you only want to cook a single serving of something. But if you want to cook, like, lots of something, I'm on a diet, so I don't eat French fries anymore, but if you wanted to cook enough French fries for everybody, then what you would want is neither... You don't want to use the microwave because it doesn't work well. The regular oven works okay. So-called air fryer is too small. You can't get more than a couple of servings in there before it stops working. Countertop convection oven? Maybe. Depends on how big it is. Yeah, if you're making a whole lot, though, then what you want is a regular convection oven. Turn it on, let it come up to temperature, and then don't use a sheet pan. Use like a metal cooling rack and put your fries on that, and then toss them in. You want the rack because it lets the air get underneath as well. Right, so convection oven only works partway as well if you use a pan, because the pan is solid on the bottom. If you're going to use the same trick for a chicken, though, you're probably going to want to put a second oven rack underneath it and put some tin foil or a baking sheet underneath it, because fish and poultry and that sort of thing, those all are a little bit drippy. And if they drip on the bottom of your oven, that can burn. And then that's gross. Smoky. Sets off your fire alarm. Makes you look silly. Ask me how I know. So band gaps are not due to human perception. not working because I need to create the actual new presentation first. This is not super practical, I guess, but it definitely is an example of how we can use some relatively advanced mathematics to learn new things. Maybe I'll bookmark lecture 9 here, because I definitely want to whatever professor or teaching assistant wrote this didn't even credit themselves, just gave the course number and the year number. 21 years ago they wrote this for Astronomy 3730. Normally you would say 373. Wonder if they use 4-digit numbers at colorado.edu. Wonder if PGA was the person who wrote this. Could be. Theoretical and computational astrophysics. Well, Phil, if you were the one that wrote that, thank you. You answered my question wonderfully. It's a thing where if sound keeps going up in pitch, but you keep adding new sounds at the bottom, it sounds like it's going up forever. I forget what it's called. Learned about it a long time ago in a By Heart video. She doesn't post very much anymore. Well, she never posted very much. She posts almost never anymore. Lots of math and music overlap over on her channel. Probably learned the missing harmonics thing there too. Touch is weird, because your sense of touch, right? You feel pressure, right? When you press against something, right? That's a sense of pressure. That's a different set of nerves than the ones that measure heat, right? Which is a different set of nerves than the ones that measure pain. Right? And itchiness does not seem to be an actual intentional sense that we have. It's more of a misfiring of some of the other ones, right? So things that make you itchy. Yeah, itchiness seems to be a bug that the body kind of used to turn into a feature. Lets you know when a bug bites you or something. Kind of the same thing as spiciness on the tongue. So spiciness is not a proper taste. Spiciness is capsaicin binding to a receptor for other things. Probably the heat receptor, which is why we consider it, physically hot. Right? That's why we use hot to mean both high temperature and spicy. Yeah, but it's a side effect of capsaicin binding onto some receptors. And the plant probably meant that chemical to dissuade us from eating it. The theory is that pepper plants didn't want mammals to eat them because we digest their seeds. Unlike birds, which can eat the pepper and then not digest the seeds and then spread them out. Although as a survival strategy, it's always been noted again and again that being useful to humans is the #1 survival strategy in the current world. Oh. So those silly, silly peppers, they tried to convince us not to eat them because they didn't want us to eat their seeds. But we decided we liked the spiciness. So we collected the seeds and planted them carefully. So, survival strategy failed successfully. Honestly, smell is probably the most reliable sense. There's a couple of ways you can fool it, kind of like how we fool taste with capsaicin. It's very closely related to taste. Yeah, but smell is just a bunch of chemical receptors up in our nose. Whenever a molecule touches those receptors that are compatible, it goes, oh, I saw my molecule. There's not a whole lot of processing. Actually, there is a good smell one. So, you probably know that your nose is connected to your throat, right? Because you can breathe out of both your mouth and your nose. If you take a smell in through your nose, it smells one way. If you take a smell in through your mouth and then blow it out through your nose, it smells different. So your nose can tell whether you're smelling from the front of the nose or whether you're smelling from the back of the nose, from your mouth, basically. So that might be an interesting video. That's probably so that you know the difference between things that smell good to be around are not necessarily things that smell good to eat. There are things that smell nice that tell you, hey, this is a good thing that I should be around. But if you put it in your mouth, your nose goes, oh, no, 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 don't put that in your mouth. It's good to be near it. It's not food. But yeah, having particles from what you're eating go up through your throat and then out through your nose backwards is why things don't taste like anything when you have a cold. It's stuffed up. On the other hand, things don't taste like anything after COVID because COVID has damaged a bunch of your nerves. You're going to have to reteach your nose how to work to smell things. Yes, there's physical therapy for that if you lose your sense of smell. It doesn't come back on its own in a couple of months. See a doctor. There's physical therapy for that. I think that's the only smell is strongly linked to memories. That's just because the active part of your nose is like directly connected to your brain. Right? If you've wondered why the outside of your nose is on the front there, it's because the nerves in your nose go straight up into your brain. Direct connection. Yeah, that's why a smell will remind you of somewhere that you were when you smelled a similar smell. I wonder if you could use that to your benefit for things like exams. Like, if you always put a certain potpourri out when you were studying a given subject, and then take a little bag of that to your exam. And when you're struggling to remember something, take a sniff. Maybe that would spark a memory. Excuse me, I'm getting sleepy. I think I'm gonna take a break now. Back in 10 minutes or so. Boom, boom, boom. Olives. Not olives. Packaged in olive oil. In case you're the sort of person that likes olives with your olives. As it happens, I am the sort of person who likes olives with my olives. These ones are just a little bit bitter. My personal taste would have preferred if they were just a little bit riper and if they had cured a little bit longer. So the reasons olives can taste bitter is because they contain a bitter chemical, obviously. But it goes down as they ripen, and as you cure them, right, you can't eat raw olives. They're inedibly bitter. If you've ever tried to eat a raw olive, and not like the ones at the grocery store, because those have been cured, but like one off of an olive tree, no, don't do that. They taste very extremely unpleasant. You have to wonder who was the first person that thought, you know, if I pickle these in salt, right? Salt cured olives are probably the earliest ones, right? But if I pack these in salt, let them sit for a couple of months to break down the bitter compounds, these might be tasty. I suspect that's not how it happened. I would bet that olives were first used for their oil, right? Probably not as a food oil either, probably as a lamp oil. It's burned for light, would be my guess. Then somewhere in that process, I would guess somebody accidentally noticed a way to remove some of the bitter flavor. You'd be probably surprised to find how many times in history something has been discovered because somebody forgot their hands were dirty and stuck their finger in their mouth and got a taste of some chemical or another. I have similar questions about cassava starch. Because cassava root definitely is poisonous. Bro here is pale enough that he's triggering my too bright filter. Sorry about that, kid. Yeah, cassava root definitely is poisonous, so I'm not sure where the idea of grinding it into a paste and then washing the starch over and over again until it's not poisonous anymore came from. It seems like a lot of work for what has become now mostly associated with boba tea. I like tapioca as a pudding ingredient, though. I think it makes a tasty pudding, kind of like rice pudding. See, it's a drupe, like a plum, a peach, or a cherry. Yep. In fact, I have an olive bitter that I use to pit cherries sometimes. I had to use a drill to make the hole in the bitter bigger, because cherry pits are bigger than olive pits. Other than that, it works just fine. Oleoropia. This sentence is a little misleading. It implies that wood ash and lye are the same thing. So you can make lye from wood ash. Wood ash is not by itself lye. Wood ash contains a lot of potassium because trees concentrate potassium. So when you burn them, the potassium is one of the things that doesn't really burn. You end up with some potassium oxide mostly. When you mix that with water, it tends to form potassium hydroxide, and that's lye. Right? But if you just use wood ash and water, you do get a fair bit of lye, but you get a bunch of other stuff too. So it's not just lye if you're using wood ash. Of course, it is probably the easiest way to get lye. You just have to make sure you don't chop all your forests down in order to burn them and turn them into ash to get your potassium hydroxide. That's been a problem once or twice. So why does salt remove the oleoropin? They're not going to tell us, are they? I want to know what the salt actually does. I mean, I guess this folktale sounds reasonable. somebody noticed that the ones that fell into the sea tasted fine. I still think it's probably more likely that it was used as an oil fruit first. Um, because adding salt is one way to purify an oil. So if you've got an oil and water mixture, right, they don't really mix. The water will absorb some of the impurities out of the oil, and adding salt to it improves the process. I'm not totally sure why. I don't know if it improves the solubility of the impurities or reduces the solubility of the oil, or whether it just adding salt makes the water denser so the oil floats more easily. Reduces the interface zone somehow. So maybe that makes the impurities more likely to migrate into the water instead of the oil. But that would be my guess, was that somebody was salting out the oil, even using salt water directly to remove impurities from the oil, and then got a taste of the oil, and then decided to try it with the whole fruit. But it could have been their story too. If so, I bet it was a kid. Right? Some kid was like, "Oh, I found a fruit in the water, I'm gonna eat it." And some dad was like, "Oh yeah, kid, go ahead, ha 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 ha," as dads do when encouraging their children to do something they know the kids will regret. I can picture that. So, and then the kid ate it and went, "Wow, this is really good." And the dad went, "Wait, really?" Yeah, if you're gonna eat olive oil, you want the extra virgin or the virgin olive oil. Because those two are mostly unprocessed. The extra virgin olive oil will taste better, but it'll be more expensive. Lower grades of olive oil have often been chemically purified. So they are not as desirable as food products. Now, the catch is that in the United States, we're used to being cheated when we buy our food. So often our food is marketed to us as one grade higher than it actually is. So when I go to my grocery store and I buy extra virgin olive oil, there's a reasonable chance that I'm actually only getting virgin olive oil. Either because the producers think we're dumb, or because Americans have learned that we just don't have a choice and can't buy nice things. Right? So chances are, if you buy the most expensive oil in an American grocery store, and then buy the most expensive oil in an Italian or a Greek, or probably, who else loves olives? Does Turkey love olives? I bet Turkish people love olives. They seem like It seemed like they would have been on the path, because earlier they said that the oldest olives they found were in Egypt, and it seems like they spread to Greece and Italy after that. So, I don't know, I'm not super good at geography, but if you wanted to go from you wanted to go from Egypt up around here to Greece, like you would go through Turkey. So I bet there's lots of olives all around here. Although there were definitely folks that were sailing back and forth across here. This is not super easy, but as opposed to crossing the ocean, the Mediterranean is relatively safe. You know, folks up in this region, up in the what's now Israel, Lebanon, Syria, Jordan, like this whole section here. Can't see my mouse cursor, I'll put it in the middle. Right, this whole middle section here used olive oil for all sorts of things. And have been for a really long time. It was one of the first skin creams as well. You got, before we had modern hand lotion, people would use olive oil for that, as well as for religious ceremonies, food, lamp oil, all sorts of things. Oh yeah, here we go. Health tonics, beauty treatments, lamp oils, and religious ceremonies. It's almost as if I scrolled past that earlier and some part of my brain remembered it, which is quite possible. See, my olives that I'm eating for my snack today are a little bit on the red side. So, not totally. They're not quite all the way ripe. If they're ripe, they would be darker. And I like them when they're fully ripe. Some in the back corner of this picture that are much darker. And I like them when they've been brined pretty thoroughly too. I don't like the bitter flavors. Some people do. Some people like it when there's a little bit of fun. A little bit of all European is good for you. I've the name of the tree. Olia, which is probably where we get olive, Europea, which is Europe, so European olive. So it's Olia, Ol. Oh, so the Ol is from Olia, and then Europe. Ol Europe. Ol Europe. See, mine are a little bit red because they also turn super black when you brine them a long time, which is why canned olives are usually really dark black. But I think the canning process destroys a lot of flavor too. I like canned olives okay. I don't hate them. I'll eat them on pizza. Although, with my diet that I'm on right now, I would eat almost anything on pizza. But I won't order a pizza. Deleted all my food delivery apps, so I can't order a pizza. And I definitely couldn't just, type the pizza restaurant's name into my browser and order like that. That's not a thing. It's interesting. Somebody's making an artificial resin to trap the polyurethane. Ferrous gluconate. I wonder if ferrous gluconate's the real reason why canned olives turn super black. Ferrous gluconate. Iron plus glucose. Oh, Laconic acid. Ferrous. Not really that closely related to glucose. Still. See, the interesting thing about glucose is that it's made of a sucrose ring and a fructose ring. Or, no, it's the other way around. Sucrose is made out of glucose and fructose. But glucose is a ring. I mean, I guess it kind of resembles these rings. Really. Right, see, gluconic acid. Yes, if you twisted that around into a ring, it would have, right, the extra carbon would go off to become, I think, a carbonyl group. Right, glucose. Right, so glucose has this ring here. Yeah. But this is behind a lot of the theory of why fructose is bad for you, is because glucose is what your body uses for fuel, right? Sucrose has one glucose and one fructose, right? So that's plant sugar. Most plant sugar is sucrose. But then when we refine it, we often refine it so that it has more fructose than it has glucose. And the theory is that since the fructose needs more processing by your body before it's usable, that it's probably worse for you. I suspect you probably should not eat a lot of pure glucose either. Oh, interesting. Uh, there's actually two different types of glucose. There's the D, which is dextrose, right? Or from Latin dexter for the right hand, right? It's the right-handed glucose, but you can also have L-glucose, the left-handed glucose, which you cannot digest. Tastes the same. You can't digest it, and neither can the bacteria in your guts. So it absorbs some water and helps things move through your digestive system instead of getting digested. But if you eat too much, it's bad for you. Makes sense. Iron is used for a lot of things in your body. So it's pretty bioavailable. Makes sense if you eat too much of it, it'll make you sick. Especially since the thing said that it'll damage your digestive system. mostly gonna get happened too long ago, nobody knows. 6,600 years, huh? That's quite a long time ago. Makes sense that they would build the brining structures near the sea itself, because saltwater is heavy, and it'd be easier to brine it if you didn't have to carry it very far. on the keyboard. They block your view of the screen. And they seem so self-assured, so positive that it's okay, that you weren't doing anything important anyway. Yes, I will give you some attention. Yes, I will. You're shedding all over my desk. You're gonna have to get brushed later. Some of this things for. I actually have a cat bed on the corner of my desk so that they can go over there and hang out and watch me work without actually being in the way. That was my compromise. Was they kept climbing all over my laptops and my keyboards and all of my stuff, so I gave them their own space. And they go over there and sit. And occasionally grab the bed with their claws and then roll over and over until they roll off the desk with it. I don't know what purpose that particular behavior serves. Is it spell this word correctly? Infinite. So in infinitesimals, there's only one L, and in infinitesimally, there's two L's. That's why I can't spell it. Maybe I'll get it right next time. Yay! I spelled it right. steal either my toothpick or the container that the olives were in. I don't think you'll like them. They're very bitter. You can't have the toothpick because the end is sharp. Yeah, you just go over on your bed and stay there for a minute, okay? feel like penicillin was an accidental discovery. I think it was one of those. So and so was cultivating bacteria in a dish, and penicillin comes from a mold. Mold got into the dish, and at first everybody was like, "Ah, the bacterial culture is ruined," and then everybody followed up with, "But it's ruined in a very interesting way." Like this mold is somehow killing all of the bacteria around it in a very precise way. We should study how it does that and see if we can take its powers for ourselves. Which is what we did. We studied how does the penicillin mold kill bacteria, and then isolated the specific chemical and turned it into a medicine. Now, since then, many bacteria have grown resistant to the original penicillin. But once the idea was out there, we started creating more and more variations. Eventually, we'll probably lose that race. Eventually, the bacteria will win. And hopefully, we've had some other idea by then. We do have a couple of other ideas right now that we're working on. Including using viruses. Yes, that's right. Viruses that target bacteria. We always think of viruses as a bad thing. But we're not the only things that are targeted by viruses. We just need viruses that target bacteria and not us. Those are called bacteriophages, in case you're curious and want to look it up. We also have some ideas that involve gene editing. For instance, bacteria tend to have genetic structures that are very different than mammals do. So we could introduce genetic modifying nano materials of one sort or another that would wreak havoc on a bacteria but have no effect whatsoever on a human cell. Trying to think. Sure, there are other stories of so and so forgot their experiment in the refrigerator or the oven for a couple of months. Oh, floating soap was one of those. I think it's the Ivory brand soap floats. And that was discovered because somebody just left a batch in the mixer for too long and it got all frothy, got a bunch of air mixed into it, and solidified in the mixer. They didn't want to throw it out, but they also couldn't sell it. So they tried using it, and somebody noticed that it floated in their bathtub. That was pretty funny. But it's late, and I'm getting sleepy and forgetful. So I'm gonna close stream. Maybe get something to eat. have a cauliflower that needs to get eaten, so maybe I'll cook that. And soon it's bedtime. Bedtime. So thanks for watching. I'll see you around.